Hello, this is my final presentation for Environmental Studies 234 called Silvopasture, Energy, and Society. Silvopasture is a process that integrates trees, pasture, and traditional agriculture into a single cohesive system. Contemporary research has proven time and time again that implementing silvopastoral practices into traditional agriculture brings a host of benefits both environmentally and socially. In fact, the commercial livestock industry could, by implementing silvopasture, take huge steps towards becoming truly regenerative. On the large scale, the carbon sequestration provided by silvopasture could play a significant role in offsetting anthropomorphic climate change. The article Ecological Considerations in Sustainable Silvopasture Design and Management from the journal Agroforestry Systems discusses how analyzing silvopastoral practices using principles found in complex natural systems worldwide could provide much insight into increasing the effectiveness of the ecosystem services that silvopasture inherently provides. For example, much of the evidence presented in this project explores silvopasture's capacity to offset GHG emissions through carbon sequestration in both biomass and the raw organic carbon content of the soil. To assist this exploration, the article lays out four distinguishing characteristics of silvopasture compared with other grazing and agroforestry practices. First, silvopasture is intentional. Combinations of trees, fodder crops, and/or livestock are intentionally designed, established, and managed to work together and yield multiple products and benefits. Second, silvopastoral systems are intensive. They're managed to maintain their productive and protective functions. This can include cultivation, fertilization, irrigation, pruning, and thinning. They are also integrated. Components are structurally and functionally combined into a single integrated system so that the land can reach full productivity. Finally, silvopastoral systems are interactive. They actively manipulate and utilize the biophysical interactions among the respective components to truly optimize crop yield and carbon sequestration. The study high-density silvopasture systems for quality forage production and carbon sequestration in humid tropics of southern India tested 6 different fodder production methods against the prevailing monocultural technique. It turns out that a 2-tier hybrid Napier fodder grass paired with mulberry trees and Stylosanthus shrub forage was found to be the most promising system for meeting the needs of both farmers and the environment. As you can see on the diagram, hybrid Napier grass is very good as both a forage and a fodder crop. It's perennial, it has a high yield and great nutritional quality. Stylosanthus shrubs are a perennial legume. It's a common forage crop in the region. Mulberry tree leaves are another very useful forage crop that are most often paired with traditional feed as it increases feed digestibility as well as dairy quality. While the 2-tier system may not be the best in purely dry fodder yield, it is the most strong and well-rounded choice in crude protein yield, carbon fixation rates, and fodder quality. Interestingly enough, adopting these systems can meet 1/3 of the annual dry matter and crude protein deficit of the Indian livestock industry and half of the carbon emission standards of India's INDC commitment over a period of 10 years. Next, I'm going to be presenting 2 studies from Mexico. I chose Mexico because it has a lot of room to grow development-wise, but it also has huge variation in temperature and conditions across the country, so I mean to demonstrate the variability of environments that silvopasture can fit into. There are 2 studies, one from Chiapas, Mexico, which has a tropical environment, and one from Michoacan, Mexico, which has more of a dry, arid climate. This study was called Carbon Stocks and Tree Diversity in Scattered Tree Silvopastoral Systems in Chiapas, Mexico. It mainly explored the carbon storage capacity of scattered tree silvopastoral sites in the humid tropical environment of Chiapas. Scattered tree silvopasture differs from other forms, as trees are simply left standing in the process of clearing land for pasture. The study found a significant correlation between living tree biomass and average soil organic carbon concentration. In fact, the presence of trees on pasture lands alone increased living biomass, litter carbon, as well as soil organic carbon concentrations. The total above ground carbon stocks were 5 to 7.5 times higher in the silvopastoral system compared to open pasture itself. It's important to note that as there's a major difference between the ages in each respective pastoral site, it would definitely affect soil organic carbon concentrations, creating the discrepancy that's shown in the graph. The next study is from Michoacan, Mexico, and it's called Carbon Storage in a Silvopastoral System Compared to That in a Deciduous Dry Forest in Michoacan, Mexico. The researchers here evaluated the amount of carbon stored in the biomass and SOC, soil organic carbon content, of the three environments: deciduous tropical forest, DTF, silvopastoral systems, SPF or SPS, and grass monoculture, GM, as you can see on the right side of the screen. The silvopastoral system was a mix of guinea grass and river tamarind trees as forage supplements to normal feed. Michoacan, Mexico is a dry tropical environment, more arid than the others I've covered. Interestingly, the total carbon stocks of the silvopastoral systems were nearly equal to that of untouched dry tropical forest. This means a great deal to offsetting GHGs emitted by livestock. In dry tropical conditions, the silvopastoral system displays enormous potential for increasing biomass and soil carbon stocks compared to the grass monoculture, and can thus be used as a greenhouse gas mitigation strategy in livestock production systems throughout Mexico and the world. Moving on, we come to silvopasture for the people. Silvopasture has many benefits for farmers, including increased economic diversity for independent farmers through perennial crops and the capacity for bees, growing mushrooms, and many other forms of secondary income. A concrete example of this is how a departure from monoculture could aid in filling in food deserts in the Midwest with the potential crop diversity provided by silvopastoral programs. The check marks that you can see in Virginia, North Carolina, and Minnesota are 5 case studies that integrated unique silvopastoral approaches to normal livestock production. The first of these case studies that I'm going to cover is in Regeneration Farms, where Tony Wells incorporated Tree Range Chicken brand created by Reginaldo Hazlitt Murrow Queen. There's one production unit that consists of a chicken coop and 1.5 acres split into 2 paddocks that have perennial hazelnut trees planted on 12 to 14-foot row spacings with 6 to 8 feet between them. The system is designed to produce batches of 1,500 chickens, which rotate between the 2 paddocks. It's also designed to mimic the natural conditions in which chickens evolved, a jungle environment with shelter and forage. Also, by strategically placing the feeders in different areas, they're able to alter which areas within the paddock are receiving animal impact. This is highly important for soil health as well as plants, and they need adequate time to rest and recovery between animal impact. This system also utilizes hazelnut trees that in 5 to 7 years, when they grow and are at full production, will produce 30 to 50% of the total current farm revenue. This is the last set of case studies that I'm going to mention, and they were conducted by the U.S. Forest Service. 4 farmers in North Carolina and Virginia cleared existing woodland, leaving trees in some cases, and replanting trees with timber value in most others. They then proceeded to plant forage in the undergrowth for their cattle. The study took place in the foothills of the Appalachians, the flat Piedmont regions of North Carolina and Virginia, all the way to the southeast coastal plains of North Carolina. 3 out of the 4 farmers involved were very happy with the results and report that they will continue to expand silvopasture on their property. This further proves that silvopastoral practices are very versatile and can be implemented almost anywhere. The 3 farmers that reported positive change in the quality of their livestock through marketing value and meat quality. There were also positive reports about cattle sheltering from the elements in tree stands. They also plan to sell the timber and lease the hunting rights to the pastures when the time comes. The process that these farmers implemented required relatively little effort and required low costs compared to other more intensive silvopastoral systems. So this study could serve as a great template to easing reluctant farmers into silvopastoralism. Conclusions. Through all of the studies and evidence that I've presented, I feel that it is absolutely clear just how beneficial silvopasture could be if we fully integrate it into our world's agricultural system. The anthropocentric value is great, but silvopasture has the potential to be one of humanity's greatest assets, not only in regenerating our Earth, but augmenting the way in which we relate to nature for the better. Silvopastoral practices are ancient and have been largely left behind by the modern world. It's time to bring them back to the forefront of agricultural science and conduct more rigorous research into the potential applications silvopasture could have. It's time to develop these dynamic relationships with our local ecology and come to fully appreciate the cyclical nature inherent to Earth and its environments. Perhaps this and enough time will allow us to cultivate balance in nature and in that become its stewards.